Hello. Today I want to fix our radical system. So in previous videos, I explained what the radicals were and how we treat them slightly differently from how they really are. And if you want to get more context about what I'm talking about, you can go to those videos. Anyway, the main thing I want to fix is that we have four characters here, four radicals here, which we're treating as all the same, and that is causing some problems because it means that our we have lots of characters sharing the same radical stroke count key. And so if we look at last rank contained, which with a feature we implemented in the last video, you can see in this range we have lots of characters all sharing the same key. And as a result, it appears that, excuse me, it appears that this this line, this code line is covering a very high. It's covering too many characters, and it's not able to cover like a number that's very close to 1250. It's covering down to rank 1552, which is too high, and that means that as a result, other lines are not covering like a better rank range. They're covering less. And so what I want to do is I want to, for now, I want to kind of uh, separate these into separate radicals again, and as a result, see how this line changes, and see if this rank here gets closer to, excuse me, gets closer to 1250. Let me take a drink of tea. Okay. Now, this is this I don't think is going to be very hard to do. So let me go and uh, double check something here. We want to see radical order. So there's a place where we actually do the conflation of the radicals, and I think that's in source. Now that I think about it, it's in check kanji database order, and let's see here. Okay, here. All right, and we have these two considered the same. We want to keep that, and it's very noisy in the other room. Let me pause the video until things calm down. Okay, I think things have calmed down now. Anyway, so we are conflating these two radicals, which we want to keep because these really are confusing, and they're not causing a whole lot of clustering over here in this section. Although we could confirm that, I suppose. So yeah, there are not looks like there are not even that many characters that have these radicals. See, just these three that are in this in our two key input codes. So this is not going to cause a problem, and this I'm guessing may be a little bit of a cause a clustering problem, but I think that it's probably worth the cost because they're like surprising kanji in this range. Where is it? It is um, let me do well. It should be J J J. Okay, here we go. It is over here, and yeah, these are some of the characters, and this does not seem like a very big cluster to me. This is a larger cluster, but I think these are all the same radical anyway, so it's not going to help to change it at this point. And yeah, these all this doesn't seem like a big enough clustering problem to backpedal on that. So I think that we do want to fix this area though, because look, in this cluster we have like the most common radical to have is nimben or hito, which is this one, and the ones that aren't that are like here 1, 2, 3, 4, 4 out of this big cluster. And so we can get this cluster to be much smaller. And the thing is, the only character that I think is confusing if we decluster these is this one right here, because some people may, because it's confusing about whether or not this radical is this character or this character, right? And so this is the only one that gets kind of confusing. The other ones, I think people are not going to have a problem figuring out what the radical is. And so I don't think that conflating this is really helpful. And plus, one of the benefits of learning this input system is that you should be able to use a dictionary better. And if we conflate all these radicals, these like four, how many are there that we're conflating? 1, 2, 3, 4. Then you're gonna not learn the correct order of these radicals, and so it's gonna be a bit of a shame. And that may not be the best reason because you can always learn them separately. But I think that in any case, we want to get these clusters smaller. In this cluster, for instance, okay, there's only 2 that would be split out from this cluster if we followed through with this. So that may not be that cluster may not be super affected by this. But this one, it has 1, 2, 3 characters that would be split out of the cluster once we finish this. So let's do this and see if we like the results over here. See if the new the effect of doing it like makes this look a whole lot better. All right, so let's like save it. I'll save it in before for now, and that way I don't have to run I don't have to run the test because the tests may not actually run this particular case because other tests before it are going to fail, and so I'm just going to run this directly manually and save the results and then do a diff manually later. So this is not going to be true anymore. We're going to delete this, and that means that over here, I think that these characters aren't affected by this change because they have different radicals. So yeah, these keys are ones that have the manually entered radical stroke count keys. Because they were reasonable keys to add, but they for some reason were not in the dictionary given by Unicode. And okay, now we go to Kanji database and we're going to resort the characters. Now, it just so happens that because these characters are rather simple, I believe that the Unicode code point is going to be the correct order for them once we don't stop conflating them anymore. So I'm going to just grab these out and put them in a separate file, and that goes up to oh no, these are one-stroke characters. Those are fine. We still want to continue to conflate those because the clustering for those one-stroke radicals is not very high. But we do want to fix these characters. Okay. Okay. Let's see how far it goes. Looks like that's it. Okay. Now I will do into unsorted, and oh, I should probably use Vim to actually do the copy and paste here. So all right, there it is. So I'll go temp unsorted and paste them here. And so a very naive kind of sorting, just using the sort command should do what I want, because we want to use Unicode code point, and this is in UTF-8, and UTF-8's sorting by the UTF-8 bytes should be equivalent to sorting by the Unicode code point, since the UTF-8 bytes are just kind of an expansion of the Unicode code point bits themselves. Excuse me. Okay, so okay. Now let's check that this sorting looks correct. So it's putting these out here. This radical comes after hito, and that's so this looks correct. This one also comes after, and then so this one should not be after. This one should not be so far down. This one needs to be. This is sorted differently because this is considered to have a different radical that comes way later than these two-stroke radicals that we're looking at. And this one also should not be all the way before all the other characters. That's not correct. So we're gonna have to fix that manually. So anyway, temp/sorted, and then I'm going to open this. Oh, actually no. We can go back to here and paste it in. Sorted. Right. Now here, let's move this character down, and no, it's too early. It's gonna have to count some strokes. So this has 1, 2, 3, 4, 5, 6, 7, 8 plus 1, 2, 3, 4, 5, all right, 13 residual strokes. And this one right above it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that's close. Where was it before we sorted it? That would be easier. Less temp/unsorted. Okay, this was right after this character. So let me cut it again. Put it right after here. Okay, good. Okay, so let's go ahead and set the cutoff points for the radicals themselves. So this is a cutoff point right here because it's a new radical. And this is a cutoff point also because it's a new radical, and this is also a new radical. And this, let me see, let's just pick a dictionary that I usually use and see what character this radical is considered, this character is considered to be under. Actually, it looks like there's no, it's interesting that there's no other like character in this radical except for these two. I was a bit surprised about that, but that kind of makes sense because I can't think of any other characters that would have that radical. So okay, I'm pretty sure a Chinese site will tell me the radical is this enter. Yeah, it does. But what about a Japanese site? Maybe. Well, that didn't work. Yeah, Google has this habit of giving me Chinese sites when I want Japanese ones. I guess I need to do something like this. Oh, there it goes again. Still Chinese sites. Wait, am I using the wrong word here? The wrong character to ask for a dictionary? Let's try something else. Stroke count. Here. stroke count and radical. Forgot to copy this. Okay. Finally, according to this one, it's enter as well. So let's just keep it as that. And we will change that to a cutoff point. Now we want to fix this character. It's not in the right, because it's not in the right spot. So let's see where it was in the unsorted, which is actually sorted, but it's using the old sort order. Okay, it comes right after this one. So let's cut that and search for this one. There. Let's see, does this stroke count match? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, good. So we did not set the cutoff points for the there should be new cutoff points in between the radicals, which I did not set. But let's see what happens. Let's see if I can get away with not doing that. So I'll do make the binary and new sort last rank contained. Okay. Oh, but actually no. What I need to do first is I need to check the kanji database order. Okay. And there's an error at this one. Okay. Why would there be an error at that one? That one seems innocuous. This is in the hito radicals, the person radicals. So that could explain it. Okay. So apparently this is the one before is considered to have 10 residual strokes for 0A. And this one has 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this one has to come before that one, I guess. And then does the one before that? Yeah, because the one before that does have 9 here, so that should be okay. Let's try again. Okay, new error. Okay, so let's move this character. This character just needs to go down a little bit, apparently. And I'm not sure why this one. Yeah, this one is kind of like, this one is one of those ones where I guess Unicode and most Japanese dictionaries don't agree on what the stroke count is. The residual stroke count is 10, 12 minus 2. And this one is, let's see if I can count it just without using a dictionary. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 8 residual stroke counts, I guess. No, I think it's probably 9 because I counted some together that I shouldn't have. Okay, it's 9. And this one was 10, correct? Yeah, so this has to go even lower. Maybe down here? Let's see how many strokes this is. This is 10. Okay, so it's the same. Good. Now we can try again. Alright, new problem. This one. Okay. So, how is this wrong? What is the before sort? Where did I store it? Is it home before? No. Oh, I did it in unsorted. That's why. Okay, this came a little bit later. For some reason, I just put it in the wrong spot, I guess. And this goes down. Where does it go? Goes under. Oh, wait. It's this one that's wrong, right? It's this. So let me search for this. Okay, this one goes after that. Okay. I thought I moved it. Didn't I move that one? That seems familiar. Oh well. Oh, I moved the wrong one. That's why. So this one has to go up. This one has to go up here. Okay. Okay, new problem. Okay, less slash temp slash unsorted. Let's see where it's supposed to go. The one above it is, I guess, the wrong one usually. So this has to go. Yeah, this is quite different from what it was before, huh? So there. Okay, then this, and then this, and this. No, this. After. So I think what I want to do is probably maintain this original order for everything except for like everything except for the new characters we pulled out here. And so maybe I'll just do that off screen since that is a bit boring. But I think that maybe for now. Okay, that one's wrong. Where is that over here? That one is right here. Okay. So I've already forgotten which one I'm trying to find. It's that. Okay. So this one is probably the one that's wrong. This comes after here. Okay. This, and then comes this, and then comes that one, and comes this, and this, and this. Okay. Okay, that one's still wrong. What did I do wrong? I must be mixing myself up. This. Okay. It's oku that's wrong, and that one is up here. Okay. So I guess this one is in the wrong spot. Jin. Jump cut. So I go ahead and fix that that one character Oku that I kept on accidentally moving into the wrong place, and now I've taken a different strategy. I'm looking at a diff, and I'm looking for all the places where a character has been added back in, or it looks as if a character has been added back in, and moving them back into the right spot. So essentially, this means that whenever a person radical character looks like it's been shifted in the person radical space, I move it back to where it was. And that way we know that the cutoff points are going to remain correct. And there's probably a better way I could have done this. I could have added some sort fields into this, But I didn't actually. It didn't seem like it was worth it to do that, because then I'd have to be pretty careful to check the correctness later, and and I also didn't feel like continuing the manual work would be that bad. So I'm just continuing to do this now. So this character comes right after Anadoru, right here. Okay, now those are in the right spot, but now this one has been moved out of place, so I have to put that one back. That one means believe, and that is 1, 2, 3. That is down here, and this has to go up here. Okay. Now this one has to be moved into the right spot again. This one goes over here. Oh no, I may have went too far up, I think. It goes in... It goes in the one with rank 2123. Here it is. This goes right above that, no, right below that one. Okay. Now this is going to have to be put in the right spot. This is one with rank 443, and this goes back up before 3348. Okay. And now these ones. This means umbrella, kasa. And this goes over a little bit up. It goes near 1719. Where does it go? It goes right. It goes right below 1759. There. And then this one should be up here, right below 1379. 1379. Okay. And then this one goes right below 355. All right. Now here's another one that's out of place. This one goes right above 1799. This is above 1799. Okay. And I think that's all the person radical characters. All right. Excuse me. I have a runny nose. Okay. Now let's look again. Okay, no person radicals are out of place. I think that now I can go, while I'm reading this, I can go and check that these ones that were removed are added back at the end in the same order. So here... Oh, but this is tricky because this comes before the people radicals. Let's make sure it's... Yeah, it comes in... No, it comes in where? It comes in after. Yeah, that's what I thought. Okay. Oh no, that's not what I thought. But it is correct now that I think about it. Okay. So there's only 2 characters in the dictionary with this radical, and they're right here. Now one, excuse me. This could be put with the people radical ones, but I can't really think of a good reason to move it there. I suppose it's fine right here. It would be nice if this could be in the in one of those 1-character codes, so that way people don't have to worry about it, because this is the only one that seems like it's kind of ambiguous. And so if this were one of the one character codes, it would be right there in the initial keyboard that it shows you when you haven't typed anything. But I don't know if it's worth it to like go out of my way to make that happen. So anyway, yes, so these two we don't have to worry about. Now we're in the Hachi radical 8. This is right here, and I think I can just count the strokes. So this is 1 2, this is 1 2, this is 1 2 3 4. Okay. So this is a cutoff point, and this is 1 2 3 4. This is a cutoff point because it's 2 more than the one before it. 2 more strokes. This is 1 2 3. Oh, this is 1 2 3 4. So let's see here. Let's see how many strokes the dictionary thinks this is. Here. This is 5 residual strokes. So, and this one is 4. So that makes sense. And then this is 1 2 3 4 5 6. 1 2 3 4 5 6. Okay. This is also a cutoff point. And this one is 1 2 3 4 5 6. Okay. But this is more common than the one before it, so I'll move it up here. So this is 6. This one is 1 2 3 4 5 6. That's 6. 1 2 3 4 5 6. This is also 6. And this one is 1 2. So the Hachi characters, the radical part is these 2 at the bottom that are separated by 2 other strokes in the middle. So this is 1 2 3 4 5 6 7 8. And this one before it was 1 2 3 4 5 6. Yeah. Wait, 1 2 3 4 5 6. And this one was 1 2 3 4 5 6. Okay. So this one is different. This one is, let's just count one more time. It's more than 6, right? 1 2 3 4 5 6 7 8. All right. Great. So the Hachi radical characters are fine. And I think that's, is that all of them? There's Hachi, there's Hairu go into, and then there's this one. Okay. So let's see here. Oops. I'm scrolling around in the terminal emulator with the mouse wheel and it's screwing up the Vim view. Sorry, here we are again. 1 2. Okay, so that's obviously more. And this one's also 2 residual strokes, but it's more common. And this one is 3. Okay, so here's 2 residual strokes. That's a good one. Then 1 2 3 and 1 2 3 4. This is 3. This is 4. This is also 4. And this is 1 2 3 4. This is the most common one with only 4. 1 2 3 4. 1 2 3 4. 1 2 3 4. 1 2 3 4. And 1 2 3 1 2 3 4. 1 2 3 4 5. Okay. And then 1 2 3 4 5. That's fine. And this one is 1 2 3 4 5. 1, 2. Okay, we're in 5 residual strokes still. Now this one I think is kind of ambiguous. Let's see what that dictionary says. So sometimes it's ambiguous, but that's only because like the Chinese dictionaries continuously give one value and the Japanese continuously give another, and I want to go with the Japanese ones because this is for inputting Japanese. So this is 1 2 3 4 5 6 residual strokes. Okay. And this one above was 5, so this is 6. This is the most common character left in this radical set. This one is less than what we just did a second ago. Okay, jump cut. So I just stopped the video and added in a bunch of stroke counts after the characters because this sequence has two characters that are ambiguous and I was getting confused very easily. And so I just added in what stroke counts I wanted to consider them all to have. And so here we can see that 5 are all below on the top, which is right, and then this one also has 5s, and it has a cutoff. It's the cutoff point. So this only has 4, 1, 2, 3, 4, so that's fine. And it looks like the rest is just missing the cutoff point thing. So there we go. Now that should be fine. And we already checked Hachi, this area. Now we are the rest were not affected, so we can get rid of these. Right, and the cutoff for Hito characters or person radical characters or Nimben characters will were always used for cutoff points. I saw so we don't have to worry about the cutoff point being lost. Only for the other character types, the other radical types, do we have to worry about that. And I've already made sure that we've added them back in. Okay. Now, we need to make sure that the people radicals are all in the correct position. Okay. I see it's just, so far I'm seeing it's just removing the non-person radical characters, which is good. And here we go. Yep, that looks pretty good. Now we can make the binary and run. Let's see, new sort. Let me close this window here. Don't need that. And then I will run the binary cd new sort / source and new sort. Check kanji db order is fine. Okay, that one passed. That's great. Now we want to do last rank contained with cutoff. Okay, now this is too big for the screen. Now, excuse me. So we have, so the numbers down back at the back here look better to me. I don't see the one that was 1500 or so anymore. And that's very good. These clusters look correct to me. And meaning I believe they do all have the same stroke count. All right. So let's put this in after and compare before and after. So it was 1142 and 1552. Actually, let's focus on this, which is the offset, the offset from the ideal rank. And this was -3, 3, and 1, and now it's 1, -1, and 1. So this is a much better balanced setup, definitely. And so we're gonna have to fix some tests, and I want to add that feature that I was thinking of, which would print out the command to actually update the expected output file to what was actually the actual output file in case the test failed. And so we look for where so here's where we do a diff, right? So there's the diff that we have to add the copy statement underneath, but we need to make sure that that is actually a valid thing to do. So we need to tell verify contents whether this expected file is something that was auto generated from the test case or not. So let's look for verify content is called. Okay, it's called here, and so we're going to add an argument that says int can fix with CP, and now we go here and we say if can fix with CP, then we basically want to do something very similar here. Then we say change to this, and we say 出力ファイルを更新するにはこれを実行してください。To update the output file, run the below command. Run this command. Okay. Great. Maybe I should just put this on the next line, yeah. Okay. No, that still doesn't fit. So let's just keep it how it was. Now, testutil.c. Let's make verify contents. Oh, we actually have to update the call sites. So here is we cannot fix it with copy, and here's we can. Okay. So let's commit that change. Are we on the pending branch? Okay. So we can say git commit testutil.c, and this is show cp command to fix test output file. Okay. Now, so we are going to go ahead with this fix. At first I wasn't totally sure we would do it, but now I do know we want to do it. So we'll actually fix this part. We're going to change this so that it's correct. Alright. This is A, B, C. Oops. This is A, B, C, D for the hexadecimal value of the radical numbers. All right. Now we can run tests. Let's just run all the CP commands blindly. We can always make sure that they're okay later. Stiff. Okay, last rank contained test beauty kanji test rank sort. Okay, this needs to be in a separate file. This needs to be moved to a separate file. Excuse me. So here, let's fix this one. And let's check what we've changed so far as tests are concerned. So we've changed this. Last rank contained test. Now, we haven't changed any code, so I'm pretty sure that as long as the output for the one that shows the clustered characters looks correct, this one should be fine as well. And as long as this one doesn't look terribly off. Oh, this is kind of weird. So this is no longer typical anymore because it's using the wrong cutoff point apparently. So the problem is that this line is covering too long of a range, which means basically that this cutoff point is too early. So we have to push it back a little bit, and so we should push it back to the next cutoff point. And this is the cutoff character for the one with the person radical and 7 residual strokes. So we need to find the first character with that has 8 residual strokes, because that will be the next cutoff point. So I see. Let's go to the kanji database, and we have typical kugiri kanji. So all the test cases that have this typical kugiri in it, they all use the same cutoff characters, I believe. And so we just have to do this, figure out the best replacement character for, and then apply that to the other tests as well. So here, the next cutoff is this one right here. So we're going to fix it with this. So I'll just remember that character. Well, I can actually fix this test right now. It is in last rank contain test here. Rank sort kanji test. Okay. And this one's not in a separate file, so we're going to have to fix it later. I think we're going to have to move all the characters, all the tests that are not in a separate file now to the separate file. Okay. Let's run the tests again. Okay. Okay, this is better, but it's still off base. It's still off balance. Let's go to the next cutoff character. So we'll go to kanji-db.c and look for this. Now, what's the next cutoff character? It is... So this one has 8 residual strokes, and this one probably has 9. Let's make sure it does, and we're not skipping any potential cutoff points. Yes, it has 9. Okay. So we'll replace it with that. Edit last rank contained test. And oops. Here, that character. Now let's try it again. Kanji test. Okay. Now this is much better, much more reasonable. Okay, that's good. So, all right, now we're going to want to stash this. Basically, we're going to say, let's add all and commit and say this is removing radical conflation for, what radicals were they? This, and this, and this, and the other one was, let's see, can I find it? That's good enough. That's a katakana approximation of the radical. So I'll rewrite it later. Okay. Now we're going to go back to number 2, and we will call this out file, right? And we're going to change the other tests inside of last rank contain tests to have separate output files. Okay. So let's see here. All right, we're ready to make the change. So let's just find all of the test cases with the embedded output and remove them. Zero. This one, I guess, can stay. Maybe this, because this one's pretty short, and these are not going to change very often. This one will have to go, I suppose. I'm just wondering if I want to be really careful, I should probably save this stuff I'm cutting out. No, I don't have to do that. I can confirm that this is correct when I look at the diff. No. Darn. I forgot to reload it. Okay. Now here, we have another problem, which is that it's annoying to have to create the output file over and over again. So we have util.h. We're using xf open, which always kind of does a hard fail or a fatal cause decides that this is a fatal error if it's not found. So that's xf open. So what we have to do, I think, is we have to we can check error number and make sure that it's like see if it's no such file or directory, and if it is, we can just report, just kind of consider the expected file to be an empty string, or we can just consider it to be an empty string if it fails at all. Git grep. Do we use xf open more than once? Yes, we do. So we do need to keep this function. Okay, so test util xf open verify contents expected. Okay. So So here, perhaps what we can do is we can say if expected and actual, so if expected is not actually opened, if expected dot stream, is that what the file is, this thing is called? Yeah. If expected dot stream is null, if it's null, then okay, how do we want to handle this? Maybe we could say that int expected opened equals expect dot stream. It's not equal. Let's see. I wonder if I can get away without casting it. Probably not. There. Okay. Alright, so we have this thing. We're going to say if not expect opened, then we'll just go to failure. We'll do xf printf standard error. Could not open expected file, and we'll give it the error. Oh, maybe what we should do is we should have this util.c. We can move this this thing into a separate function, I suppose. We can do like void report fopen failure. And yeah, but then we have to do the file name thing again. We can do, I guess we can do file name and char const error, or we can just keep the error no. Report fopen failure, and I don't know how nice if I really like that very much. Report fopen failure, path name, and this will go up here. I don't know. All right. Okay, that looks kind of nice. So then we go to util dot h. Oh, h, and where is fopen? It's right there. Okay. Now, where are we? We got to go back to test util and finish writing that. Edit test util. Report failure expected fn. If expected opened, then we can print this. And if we can fix with copy, then we print that. Okay. Now, we probably want to make a separate commit for this. So we do make so here this looks like we can report the fopen failure pretty easily. No such file directory. And in order to update the file, we run that. Okay. So where are we? We are in out file. So let's we're on a new branch. So let's commit testutil.c, util.c, and util.h with the message of fixed test failure behavior when output file is missing. Okay. Now next we have last string contain test. Now we can start using the new functionality we just implemented. So copy. It fits exactly on 2 lines. Now we can run. Okay, now it looks like we have a new failure. Okay. Okay, so just to make sure that this looks correct, 1142, 1552, 1289 in the new output. 1142, 1289 in there as well. And here looks like the numbers are the same. Okay. So now we're going to say, what is the purpose of this? We're going to move more test output to separate file. Now we can go to pending and get rebase onto out file. Alright, I guess we can delete out file and run the tests again. Okay. Okay, now we have the problem of the cutoff character is still wrong. So this is in the typical Giri kanji test rank sort test. Last rank contained test rank sort test. Actually no, it's test rank sort. Alright. This gets that new cutoff point. Okay, we can keep that one there, I guess. Not valid cookie D, that we can keep that one there. Find cookie D. That one, I guess, needs to be updated. Then kanji test. Okay, this one needs to be updated. All right, now let's try this. Okay, updated that test. Now we run this. Okay, update that test and update showing count test. Now run. Automatically find cookie D, hide kanji. Yeah, this is probably because we didn't update all. This is not typical cookie D kanji, but this is the one where we're gonna have to update the test because we have a different different cutoff layout anyway. So this is from the original change. So let's make again. Still have a failure showing count and hide kanji. Okay. I bet that's the last one. Nope, one more. Make. Okay, good. Now, let's see what's different. So this is different. This is different. Right. That's different, and it's showing spaces. Okay, so this is where it's cutting off. It's showing clusters more visually. And yeah, I do like the fact that these clusters are more sane looking, and I'm not conflating radicals. It's a lot more visually appealing, to be honest. Okay. And those tests are updated. Or those test arguments are updated. Now remove radical conflation for this. So this is part of the same commit. Right? And now, what have we done? So let's just review what we accomplished today. So we did we're showing the copy command whenever we update a test. Whenever we update a test and the test is now failing, we show a copy command so that the user can fix it more easily, or the test runner can fix the failure more easily. And yeah, that's good. So can fix with CP. So yeah, this was a very straightforward change because we're just printing out an extra command if we know that they have an expected output file that's kind of part of the repository and not a temporary file. Next commit is number 3. Fix test failure when output file is missing. Now we just kind of know that there's a failure, but we give the user a chance to run the CP command. If the CP command is actually well, we give the user a chance to run the CP command. So the thing is, if it is if this is false, then that's kind of strange, because that means we wrote the expected file ourselves, but now we're not able to open it up again. In that case, we're going to go to failure, and then we are going to have exp open is false, and it's going to get, oh no, it's going to be false, so we'll skip that. And then can fix with CP will also be false. But we also report fopen failure here, which gives the user enough information to handle the problem, hopefully. I mean, hopefully this is not some major problem with their OS or their like disk drive or anything like that. But it's certainly not something we can fix with this commit. Then, okay, that looks good. And so now number 2, this is a very mechanical change. We're just moving some test output to a separate file, so it's easier to fix in the next commit. And this one, we remove the conflation of these radicals, and the result is not really any more confusing than the result is the radical list is probably a little bit more intuitive and less confusing to people that understand radicals, and that's good. And that just required a lot of test updates. And oh, we did have to update some codes, these mapping codes. So that's I kind of forgot about that. But I don't think that it's possible that there can be any real problem here, because this is all based on the output of last rank contained. But this is using default mapping, so let's see, new sort, last rank contained. Let's zoom out a little bit. Okay, dash C to help me see a little bit. So this is going to sort it by the radical stroke count sorting. So first it has this here. Actually, no. Up here is the start of the line. Hito and koto. So that is where? This is actually 1, 1. Why is it like this? I don't quite understand. 1, 1 is that. It should be like the very first character in the database. It should be this one, if I understand correctly. I'm not sure why we have this. So where is this actually in the mapping? Let's look. It's in 1x. 1x. Why is it all the way down in 1x and not 1, 1? Maybe because it's harder to type? Mapping, make map test. But the thing is, this is not using the ease of use typing heuristic. So I'm not sure why this is actually different. I've forgotten why this is output like this. So what is default mapping? Sorry, I went too far up. Default mapping. Edit default. Well, the thing is, we haven't changed anything, so maybe, yeah, let's just make sure. I want to be thorough. Last rank, this is called make map test. And this is default mapping, make map with no arguments. Edit make map.c with no arguments. So it's going to go down here, get Romaji codes, get kanji codes. Here it's going to call kanji distribution, auto pick cutoff, and then, okay, because it always is automatic cutoff picking here. And then it populates, get free kanji codes. Free code is equal less than free kanji codes.count. So this is going to go through every line, and first key character, let's get kanji codes. Free code. Okay, yeah, it's going through every single kanji character here. So this is not a nested loop, even though I kind of thought it would be. So it is doing a binary search here to look for the key index map, Chardu key index or die. So it's looking in the kanji line stats for the right first character, for the right line, I guess. Yeah, it's looking for the right line. And then it takes one of them, takes first key I, first key index, codes consumed in that one. Okay. Then it copies the input code from the free kanji codes into the input code, and then it copies the line stats, that character code, to here. So next code I Um, oh, I guess the reason why it's doing this is because this is last rank contained with no arguments, where it's sorting by ranking. So that would explain a lot. Excuse me. Okay, so that's acceptable. I guess I'm surprised that it sorts by rank in the default case, but that's fine. Okay, so move more test output separate files. So now we go. So yeah, I guess we are kind of done now. Now that I'm convinced this output is correct. And I don't really see any other reason to be alarmed here. So I guess we'll just call this done. So that's it for this video, and thank you for watching.